This video has been supported by Anker. Hey folks, the last portable power station we featured was unfortunately sold out within 2 days. So here's another one from Anker. You've probably heard about Anker before. They are the #1 manufacturer of mobile charging accessories, with millions of products being sold all over the world. They are calling this one the Anker 521. It's a much smaller, lighter and cheaper power station than the one we featured last time. In part, this is due to a lower battery capacity and output power, but also due to larger cells and therefore less dead weight wasted in battery casings. It is built with 256 watt-hours worth of long-lasting lithium iron phosphate cells. In addition to being a lot more chemically stable, this type of battery also retains its capacity through significantly more charge and discharge cycles. This one is specified to still have more than 80% of its capacity after 3000 cycles. That's a 6 times longer lifespan than traditional NMC lithium-ion batteries. I have no way of testing that so quickly. I can't see any obvious mistakes in here, especially no tinned wires going into screw terminals. At a glance, the construction looks robust. All the heavy components are glued down, and critical parts of the BMS seem to be protected from moisture. I've temporarily modified the battery's main XT60 connector, so that I can monitor currents going in or out of the pack. When powering a load and charging the power station simultaneously, we can see the expected behavior of the charger power going to the load preferentially. However, reaching 100% state of charge disables charging completely for a few percent. This behavior is not optimal for permanent pass-through charging or UPS applications. But with these high-tech lithium iron phosphate cells, it'll be a long time before wear through microcycling begins to show. The charge input of the Anker 521 is tolerant. On paper, it accepts DC voltages between 11 and 28 volt. I suspect they made an attempt to include a boost circuit to utilize charge voltages lower than the momentary battery voltage. It doesn't work very well below 12, but the available range is still wide. There is also a built-in maximum power point tracker that figures out dynamically how far it can push solar panels and other current-limited sources to always draw the optimal number of watts without any additional devices. It seems to be okay with voltages slightly above 28 too. This partially covered panel put out around 30 if I remember correctly, so no series connection of 20 diodes necessary this time. Very nice. The USBC port on the front of the unit supports 20 volt, 60 watt power delivery, so it can fast charge phones, laptops and other mobile devices, or power a mobile soldering iron like the TS80P or Pencil. It does this especially well with no regular interrupts that with other chargers annoyingly reset the iron all the time. I'm currently receiving weird looks for soldering around in public. No sir, I'm not planting a bomb, not today. Conveniently, the 60 watt USB-C port that we are currently using as an output can also be used as a charging input, with the same 60 watt rating no less. That is very nice, as more and more electronic devices are adopting USB-C. If you're in a hurry, you can even combine the regular 60 watt DC input on the rear with the 60 watt USB-C PD input to reach 80% state of charge in a record-breaking 1.5 hours.
Spit roasting.
Most importantly, we've got a 200 watt continuous mains power output, which lets you charge almost everything everywhere. 200 watt may not be enough to power large consumers like hairdryers or microwaves, but for a road trip with a miniature Cal lab, to compare ppms with friends for example, it is just perfect. I also found it handy as a power source on my rooftop solar construction site, where an electronic load has to continuously discharge the solar battery, so that I can gather some long-term statistics about panel orientations and angles of incidence. This setup can run indefinitely because I'm charging the Anker power station right from the 12 volt solar battery. You can use it as an uninterruptible power supply for a critical Raspberry Pi server application, or for a 3D print that absolutely must not fail due to a power outage. It doesn't quite behave the optimal way for this application, in that it doesn't pass the input power straight through without bothering the battery, but I'm sure that it would work fine for years. And that is all. Thank you for watching, and thanks to Anker for sponsoring this video.